Welcome to the GOTO podcast. Each episode covers the brightest and boldest ideas from the world's leading experts in software development. Tune in for practical lessons, compelling theories, and plenty of inspiration. GOTO gathers the brightest minds in the software community to help developers tackle projects today, plan for tomorrow, and create a better future. Stay up to date with the latest in tech through GOTO's top-rated events held online and in person in cities like Amsterdam, London, Copenhagen, and Chicago, and by subscribing to the GOTO Conference's YouTube channel, where you can find thousands more high-quality dev talks. Learn more at gotopia.tech.
Hello and welcome to the GOTO Book Club. I'm Peter. I'm a freelance low-level front-end web tech person. And with me, I have my friend and podcasting buddy, Stefan Baumgartner.
Good morning, Peter. Hi.
Hi. Welcome to the show. I guess you did it again, right? You wrote another book on TypeScript.
Yeah, so that's right. After I wrote TypeScript in 50 lessons in 2020, I wrote another one, the TypeScript. Oh, cool. You have it. Fantastic.
Of course.
I have here the follow-up, the TypeScript Cookbook. Exactly, which is sort of a sequel companion to the first book. And yeah, I wouldn't have thought that I would write another one, but here we are.
Yeah, this was, of course, going to be my first question. Why another one? I mean, you said that it is kind of like a sequel, as in builds on top of the first one?
Yeah, in a sense. So you can consume both books totally independently from each other. But I guess it was a sequel in terms of where I was and what I needed to write to continue with TypeScript. The first book, TypeScript in 50 Lessons, I always intended to have it as a timeless, if you will, introduction to the TypeScript type system. So with TypeScript in 50 Lessons, if you read it, you understand the basics of the type system. You can go out, write TypeScript in real-world projects and know how to navigate your way around. And it turns out that once you do it, lots of questions come up, because while the type system follows certain rules, there are situations where it's a little bit off, to say the least, where the TypeScript team is cutting some corners to make things that exist in the real world work. And this is what I'm dealing with the TypeScript Cookbook. So the TypeScript Cookbook is full of real world scenario stuff that you are going to experience once you're writing TypeScript code, with lots of little solutions that help you solving those issues or solving those problems. So while the first one is best case scenario, the second one is real world scenario. And it turns out that while I had 50 lessons in the first book, I had about 100 lessons in the second book. So the style is very similar, so apparently real world TypeScript programming is a totally different beast.
Yeah, and the opposite of a best case scenario is a real world scenario. That's also telling.
Yeah, that's saying something, isn't it? Yeah, so the funny thing is, I really wasn't going to write another TypeScript book. So
why not? What's wrong with writing a book?
No, it's great. I love writing a book. But I thought the TypeScript chapter is over. But then O'Reilly approached me. They liked the first book and they said, well, we want to produce a cookbook. So the title was already set. And they asked me if I would be interested in if I had content for this book. And I was very hesitant at first. So I really thought, well, I've already written the TypeScript book. Do I have enough content in me to make up for a second one? And usually when you are in the negotiating phase of a book, you write a proposal. And in this proposal, you are supposed to have a table of contents of some sort, not necessarily a real one or a full one, but at least some to understand the direction the book is taking. I only spent 3 hours with that proposal, and I had about 100 items done within those 3 hours. And this was the moment where I said, okay, there is enough content in me to produce a proper TypeScript book that's valuable, that I think is valuable, and that can follow up the first book in a sense. I would say it's about 95% of new content. There are a couple of things that overlap, obviously, because some of the basics you need to reiterate, especially if you write the book with a new publisher that should be independent from the first one. So, but 95% of those 100 lessons are completely new and not in any way in the first book.
I think the only real similarity is the general table of contents, like all the stuff that you need to check off, like generics and conditional types.
Yeah. So the broad strokes are very similar. What's the type system? What are generics? What are conditional types? What are string template literal types? What are variadic tuple types? But I guess if I'm not mistaken, I had just 7 chapters in the first book and I have about 11 or 12 in the second one. I need to check. I go a little bit beyond that. I have a chapter in there about TypeScript and React because it's very popular and there are lots of nuances if you want to combine those two. Given alone the origin of the TypeScript types or the React types for TypeScript, knowing that the original is not written in TypeScript and the community tries to create types around the library that should work in a way. There's lots of real world scenarios again that you need to deal with. So I spent a chapter on that, but I also dug, for example, into classes and object-oriented features of TypeScript, which I left out completely in the first book. So
I noticed that you wrote an entire chapter about classes. We are going to get to this.
And obviously also some things like type development strategies. So if you are in a project where you need to create types from scratch or need to somehow model your domain, you have different techniques in TypeScript that are in a way different from what you know from other programming languages, especially since TypeScript is just this, thin layer around JavaScript. There's this duality between you are writing JavaScript, but you're modeling it with TypeScript, which is interesting in my experience. I don't know any other programming language that has such a duality in and in itself because it works on 2 totally different levels. And we talk a lot about those 2 different levels in this book. So we are developing types. Then we see how well do they match with the code we write that actually is being executed. And in one chapter, we are also circling back again. So we learn a lot about conditional types and make even more advanced conditional types like in the last item. And they get more advanced and more advanced and more advanced. And then we reach a point where we say, okay, is it worth it to have great type safety for a conditional type that is hard to maintain, hard to read, and where you need to work your way around with JavaScript? Or should we just take 1 or 2 steps back and say, this type is good enough for 99% of our situations, but you don't get yourself in your way when writing then the real world JavaScript. And this is when the book gets philosophical in a sense. That's what you can expect from when I'm writing stuff.
I mean, you can expect this from any good cookbook, if you ask me. And another thing I noticed in comparison to the first book is that you spent an entire chapter on project setup and talking about different stacks. I mean, React got its own chapter, but there's also the general approach with introducing types to an existing project and this entire basically setup procedure that you can go through, that you can take to different extremes. If you write a book, if you have something that actually gets printed on paper and you talk about essentially dependencies in a JavaScript project, I mean, you run the risk that before the ink is dried, that all the dependencies have turned over and nothing that you wrote matches anymore. All the screenshots are outdated. How do you deal with this if you write a book for the modern age of web development?
This is an excellent question, honestly, because I struggle a lot with the chapter to even convince myself that we need it. But so the reality, unfortunately, is that even if you know the TypeScript type system very, very well, you might struggle in wiring everything up into a project setup that actually does what you intended to do. I was very fortunate that after the first book that people invited me into the company. So I consulted them on TypeScript in a sense. And I figured out that everything that you can learn about the type system is basically done really, really quick. But getting there is the hard part. And this is what the first chapter deals with. So yeah, we are talking about dependencies. We're talking about different JavaScript runtimes, wiring up in Node projects, which is quite interesting because Node just released TypeScript support within Node, and not everything from TypeScript, but a great deal from it. So my main focus with that chapter was not only to wire up all the dependencies that could exist at the point of time where I've written it, but rather learn or teach the reader to learn about the tsconfig items, tsconfig compiler flags that make the entire thing work. So yeah, I guess I have an item that tells you how to deal with ECMAScript imports where you load a dependency via a URL. But what you actually learn is path mapping. How can you have this string identifier and map it to some types somewhere? And those config flags, they exist for a long time. They existed even before ECMAScript modules were supported in TypeScript and can now be used in this context. So the goal of the book in this particular chapter is learn as much as you can about tsconfig so you understand how those properties work together, how do type roots work together, how does the file include mechanism work or exclude mechanism work, and how do you add a particular set of types to a particular scope of your project, especially if you have a front-end, back-end project where you write Node on one side and React on the other side. You don't want to have Node types in your React code and vice versa. So how do you deal with that? And this is basically just configuration of the tsconfig JSON. And this is what you get in this chapter. So yeah, it was a fine line that I had to walk there, but actually it's one of my most favorite chapters because it opens up the idea of this cookbook really, really well. You need a recipe to solve this one issue or to cook this one dish if you will. And after you use it, you not learn just how exactly to solve this one particular problem, but also get more skill that work from a multitude of projects, basically.
Yeah, I mean, you can take your tsconfig JSON and just copy it to the next project once you have it working for one.
Exactly. Or you understand which parts to exclude or extract from it for the next project. I guess this is even more important. It's so funny because there are some properties within tsconfig JSON that conflict with each other. And this is the stuff that you realize the hard way when you think everything that you've done should work, but it doesn't. But then you need to go into some base tsconfig JSON where you inherit all the properties that you want to spread across your entire project and need to delete this one particular line to make it work. And this is where things get nasty.
Yeah.
But those are the things that are being tackled on in this book.
If you were to start a greenfield project with TypeScript today, no strings attached, no dependencies, no stack chosen for you, what would you pick in terms of build system, compiler, and a few tsconfig flags that are simply must-haves in your opinion?
Okay, no dependency at all. So I'm not forced
to use. You can choose Angular,
React,
you can write a Node project, React, what have you.
Okay. Oh, this is a tough question. I mean, for the stuff that I write very bare bones JavaScript and TypeScript. I work mostly on the backend, and it's a joy working on the backend because if you write Deno or Node, you don't need to do anything with Deno. If you want to have a couple of overrides, then all you need is a tsconfig JSON, and that's it. You can even write JSX in Deno and produce HTML output with it through a couple of libraries. So the Fresh UI library is really, really good at that. And I love that Node is going into a very, very similar direction. So still to this day, I've been writing Node for I don't know how many years, over a decade now. Setting up an Express server to handle a simple backend API is a joy. And now you have types with it without needing to have an extra transpile step. So all you need to do is install the necessary type definitions from definitely typed, have a very small tsconfig JSON that just tells you, please use those types. And that's it. So that's all you need for the backend part of things. If I would go with front-end code, I think if I had to choose a build system, it would be Vite. Vite is really one of those battery-included build systems that is very, very flexible in terms of which runtime do you want to work with, which framework do you want to work with. It's very ECMAScript forward, which means that, yes, there's a build system at the end, but first and foremost, we are a development server that transpiles whatever meta language that you're writing, if it's TypeScript or a .vue file or a .csx file or whatever, into some actual JavaScript code, but we leave the module system intact. So there's no module voodoo happening underneath. And they go into the right direction with a lot of their ideas, especially in that stuff that's coming up, which is very important to me. You can switch the execution runtimes of your tests, of your backend code, of whatever you like. And have seamless APIs for that. So I would go for that. And I would also choose their tsconfig recommendations, especially if with Deno, you almost don't need it. With Node, you have 5 lines config that is up on the official documentation. And the Bitfox also have everything already set up for you. And you can override it in the parts where you actually need to override it. So this is very bare bones, not a lot of moving parts, which is always good, and very open, very extensively. It's not that you need to download a gigabyte of NPM dependencies to get a Hello World running. It's small. It's about 20 megs. It does what it should do. There's not a lot to it. So that's what I like.
That's interesting. The man who wrote an entire book about TypeScript wants to have the most basic setup of all. Okay.
Yeah, sure. Less is more in a lot of things, especially in TypeScript.
I mean, this dovetails nicely into the first point you make in your chapter about basic types, which is essentially don't write any types if you can avoid it at any point.
Exactly. Infer types when you can. It's great. TypeScript has a very interesting point in JavaScript because it needs to somehow model everything that can happen in JavaScript. And JavaScript can do everything. And people do everything with it. And the TypeScript team is constantly chasing after folks who do some really, really weird stuff with it and try to formalize it, try to create static typing for it. And this is a challenge. Absolutely. So I applaud the TypeScript team for being able to do so much for the entire JavaScript system, which can be really, really tough at times. The best JavaScript code that I've written is still worse than the code that I write with TypeScript as my co-pilot, if you will. And and with that, TypeScript offers the kitchen sink of JavaScript expressiveness, if you will, which also means it understands a lot about JavaScript. And you can take any JavaScript file, write a TS check at the beginning and a comment, and TypeScript will try to pick up what's wrong in your code. And this already, I tell you, it goes 70% of the way. You find 70% of the nasty bugs that you wouldn't catch if you just look at that code. And the other 30% is you actively working with TypeScript on a very low level. You just need a couple of features to actually get it going. If you are not in a couple of very interesting scenarios or in scenarios where you need to work with dependencies that are either not written in TypeScript or have very interesting APIs, you come a long way with a couple of type annotations, a good understanding of the basics of the type system, and the simple check and erase of types.
So it's kind of, as usual, types in 20% of the places get 80% of the work done.
Yeah, the Pareto principle, isn't it? So.
Right. So one question I have with regards to this is when you go consulting and you come into a company where they are starting to roll out TypeScript or they are thinking about TypeScript, one thing that I get the feeling that many people like is explicitness, which is actually writing the types at all the variables, basically doing the opposite of the first point that you're making. So how do you reconcile this? I mean, people working with JavaScript, which can be quite chaotic, looking for some sort of fundamentals that tie them to the ground, that give structure to their programs. And you essentially say, no, JavaScript is fine as it is, just add a few types to add a few guardrails, but kind of don't overdo it. How do you sell this?
This is a fantastic question, and the answer to that is very, very simple, because I think both approaches can be very dogmatic. So if someone says, oh, I'm going to annotate everything because I'm used to do that from, let's say, Java 20 years ago, where you have an integer I that is a new integer of whatever, where you basically tell the type 3 times in one line. People are used to that and people like to do that. On the other hand, you have the JavaScript folks who just go willy-nilly and let's figure everything out in the end. And as with everything, there's lots of nuance in that. I tell people when I go consulting, and I'd also tell it in the book, that if you do a type annotation, you need to understand what this type annotation does. It's effectively a type check. It's the part in your code where you tell the compiler, please make sure that the types align, that what you get on one side is compatible with what you have on the other side. And then you start thinking. So if you just assign a variable to a number or to a string or whatever, do I really need to type check that because I just care about the value? But once I put it into a function or in a method call or wherever, then I want to make sure that the value that I have on one side is compatible with what I have on the other side. And you can do that in multiple ways. You can do that in function signatures. You can do that in return types from function signatures. There has been a huge discussion on the internet a couple of years ago where I guess everybody was bored and they were producing videos on whether you should need to annotate your return types or not. Stupid, very stupid discussion. But ultimately, it boils down to, do you want to check the return type or not? There might be situations where you don't want it. Maybe you just want to infer it because you are still in the process of figuring out what the return type should be. Then it's okay to not write it, but let things evolve. And also, if you declare a variable or a constant, if you put a type in there, know that this is a type check. You can put any complex JavaScript object after that, but it will be handled as this one type that you annotated with. And this can work in a lot of scenarios really, really well. In other scenarios, you have those huge kitchen sink config objects that you want to use in various scenarios for various APIs. Maybe you don't want to annotate the type there because you might lose information. And this is basically anything that the colon type annotation does. It does a type check. And from that point on, it has this type. And all the other information is gone. The only information that is important is that this type exists. And you can go down the rabbit hole with performance optimizations because basically if you do a type check early on, then TypeScript just needs to compare labels throughout the rest of the type checking process. So if it's a colon config or colon person, the moment you assign the variable, it will always be this person and every person check will be handled just fine. If you don't do that, this type check has to happen more often, but it's honestly an optimization in the microseconds part. It's really about what you want to express with the type annotation. Do you want it to be a person at that particular point in time? Or are you good with it being this God object that's getting refined later on? And this, if you understand what the compiler does at this point, it takes out all the dogmatic advice that you get or that you follow. It really makes you think that, well, at this particular point in time, I want to have that. And suddenly all TypeScript code gets much, much better.
Yeah, I mean, you're moving checkpoints around, basically.
Yeah.
That's something to note. First things, don't write annotations if you don't need to. And another thing that I picked up is don't use enums if you don't have to. I mean, if I talk to real developers who do backend code, Java, C#, what have you, they always like their types, their classes, and their enums.
Beautiful, yeah.
Now we've talked about maybe don't write too many type annotations. We've already teased that you maybe aren't the greatest fan of classes. We are going to get to that. And now you're telling me that we can't even use enums.
Again, as with everything in this book, I'm not telling somebody to not use enums. I just tell people to be aware of what enums do, especially string enums, and to an extent number enums. And this really depends on which version that you're on. So number enums were funny prior to, I guess, 5.5, 5.6. The problem with enums is that they work on a different level than the rest of the type system. The type system is a structural type system, which is clear if you think about the roots of TypeScript, which is JavaScript. You don't want to have a nominal type system where you need to have the exact name, the exact label for a type check when all you do is writing object literals that have basically no type. You want to have a structural check because you can compare those objects with some formalization of them. So this is why TypeScript mostly follows a structural type system, except with enums. String enums and number enums work in a nominal space, but also not entirely. And this is where things get nasty. So with a number enum, you have your direction enum direction, up, down, left, right. They get assigned a number. Each item gets assigned a number starting with 0, 1, 2, 3. And if you expect this particular enum at the function signature or whatever, you can write, of course, direction.up, direction.down. That's what people are wanting to use. This is what they look for when you have an enum. You have a named identifier for some arbitrary number. But in some TypeScript versions, TypeScript allows any number. You could put 1000 in there. You could be pi in there. You can put any number in there. Number enums don't type check except on numbers, because there might be areas where you do a bit mask with those enums, like you have a XOR combination of two roles. And this can be a number that is not defined within the enum. And this is why TypeScript says, okay, at least it should be an enum, nothing else. So you don't get type checks with number enums, not in the way you want it. With string enums, on the other hand, you have an enum that, are administrator roles. Enum role administrator equals string administrator. Moderator equals string moderator. So the actual literal string. When you have something like that, you can't use any other string in there. Also not from other enums. So you might think that you want that, but there are situations where this particular enum could restrict you too much, where you're not able to get to the actual value, even though this is the one thing that ends up being done in the output code. Also, enums can bloat up your output code tremendously. I was consulting a project where they had an auto-generated string enum, about 2,000 lines of code. That stuff can't be removed. This bloats up in a huge closure with a very complex object inside with all those 2,000 elements. And yeah, all they needed would have been a string union type, where you put just every value into a union. You get the same type safety, but you get the same type safety, you get the same IntelliSense from your editor, the same autocomplete features, everything stays the same. But you just get something that can be erased afterwards and something that is compatible with the rest of your type system. So no matter where you get this particular string from, it's compatible with your function signature, which means that you don't need to box it into an enum or to type annotations for the enum. You can just use that string and it will work with that one particular function signature. And there's even a way to, if you really like the development style of the enum, to recreate it with a plain JavaScript object and a simple TypeScript type. You get the same developer experience, but it will be better for your bundlers. It will be better for your interfaces to other parts of your project. You don't create code that you don't understand or that you don't expect to be created. And you can work with things at the boundaries of your application, where you take in values from the outside and use it with the type system that you have on the inside.
Mm-hmm. So this is the part in the book where you essentially have the recipe that turns an object into a plain type.
Yeah.
Right.
So you have a little object like, again, the roles object, where you have properties on the left side and string values on the other side. And you can, with asConst, lock it down to that literal value. And then you have a type where you just extract the values from it. And since TypeScript and JavaScript work on two different levels, you have the type level and the value level. So you can define the same name in the type system and in JavaScript. So if I have a const roles in JavaScript, I can have a type roles in TypeScript and they don't clash. And with that, you get the same type and the same behavior, but it's clear which part stays in the type system, which part stays in JavaScript code. And for that stuff that stays in JavaScript code, you get much, much better compatibility with everything else in your software.
And in this specific case where you're essentially taking a runtime object and getting a type from the object instead of the other way around, which is probably more what people are more used to.
Yeah. But this is, if you think about TypeScript being this one thin layer around JavaScript, it totally makes sense. You can pull stuff from JavaScript into TypeScript, but not the other way around.
Yeah. I mean, is it a layer or is it another programming language onto itself? I mean, we have stuff like deriving types from runtime object. We have conditionals. If you have generic types, they kind of look like functions with a freaky syntax. I mean, is this even just a layer and a type system, or is this something else?
So somebody figured out that the type system in TypeScript is Turing complete. So where does metaprogramming stop and real programming start? This gets very philosophical. So yeah, you can do, especially with conditional types and generics, you almost have a functional programming like experience when you basically work on a huge set of possible values and you narrow it down through certain conditions in your code and you generate new types from that. And this is immensely powerful, no questions asked. And you can do a lot of things with that. So yeah, that makes TypeScript or the type system in and itself its own programming language. But I think you don't always have to go that route. It's totally fine to have just types. It's really, really good because that's what it was made for. I mean, there are folks, it's amazing, who created a type that can read an SQL statement, and based on what you write in the SQL statement, creates an object for you with the right properties and the right types of that property, which is incredible. Folks use string types to create a dictionary. So you basically add a word to this type, any string, and it will check in a list of strings if there's an overlap with that or not. And if there's an overlap, the type will be okay. If there isn't an overlap, you get red squiggly lines. So you can have actual spell checking within the type system. That's amazing. It's great that you can do that. But do you really need it in your day-to-day JavaScript project?
I mean, I guess it kind of depends on the project, right?
Yeah.
If you're writing something that kind of takes SQL and maybe wants to be sort of an ORM, I mean, it's not inconceivable that you might want to use something like this, I guess. I
mean, it really depends on the depth of how far you want to go. But there are a couple of things that are also in this book where we take, for example, an express route, which is a string, deconstruct the string and figure out if there are any placeholders for variable names in it. And if we find those placeholders, we are creating an object where you can access those placeholders in your callback function. This is 5 lines of TypeScript code, nothing more. But the type safety that you get for this little investment is amazing because you're not picking any typos anymore. You're not just guessing the variable names. And this is where TypeScript can be really, really helpful. And where those advanced features are coming from. But it's with everything. If you give people a certain tool, they are going to do stuff with it. Stuff that you don't expect them doing with it. So I enjoyed it. I enjoyed it a lot.
Speaking of things that you enjoy, we now have to talk about it. Chapter 11. For some reason, it's chapter 11. I don't know if there's anything in this particular choice, but you basically cave in and talk about classes for an entire chapter. Now, from our podcasting sessions, I know that classes in TypeScript, specifically in your day-to-day job in the backend, are kind of not your favorite language feature.
Yeah, it's tough. As with everything, there's nuance to it, isn't it? So I have seen people when consulting in other projects who try to use classes as an excuse for using every object-oriented design pattern they can find. And you can do that. TypeScript and JavaScript are expressive enough to allow you to model your code like that, but they are not always the right choice for it. So, for example, I've seen folks who create a class that works with the environment variables of your project. They can come from the environment themselves, or they can come from, from some configuration file. And they provide accesses for it or modificators for that. And it's basically a JavaScript module with a class in it with static methods in that take the config, take an operation, and you can work with that. You can do that, of course. But it's definitely the wrong choice of technology of what you want to achieve. You want to have encapsulation for a set of features that are connected to a particular domain. Okay, this is already the module. If you have an ECMAScript module and you write functions in there, that's all you need. You have the encapsulation, you have everything of that particular domain in that particular file, and the API doesn't change. If you add this class layer on top of it and write just static methods or static functions, what you end up with is the similar output, but a file that is not compatible with 3 shakers. So you carry along the entire stuff that you've written, whether you use it or not. This is okay maybe for free functions or free methods or whatever. But I have seen people doing that over and over and over again. 100 classes with 10 functions each, and they just use a couple of them because it's an external library. And they carry along the whole library because no bundler can work with that. If it's a class, you take along the whole class. And this is what I discuss also in the book. So this is why I'm not a huge fan of classes, because there are at times better ways to do things in JavaScript. There's also a valid reason for classes. And I don't want to discuss it. If you want to have lots of instances of the same thing where you need to operate on and you want to have the operation connected to the data, fine, then use classes. That's totally good. But for many, many situations, a module and a couple of functions is just the thing to go. And this is what I discuss here. But next to that, I also discuss which flavor of classes to use, because classes have been a key feature in TypeScript since the beginning. And there are lots of features from TypeScript for classes in the language that are not compatible or that are different to what ECMAScript classes offer you. And visibility modifiers, for example, you have 2 or 3 visibility modifiers in TypeScript. You have just 1 visibility modifier in JavaScript, and they work slightly different. So what's the difference? What's the nuance on that? Which one should you use? And it boils down to, well, use whatever you like, but understand that one is actually also being rendered in JavaScript, while the other one will disappear once you transpile. And this is the stuff about classes. So in classes, I discuss which flavor should you use? Should you use a class in that particular scenario? How do you work with decorators, especially compared to the old decorators that TypeScript invented, opposed to the new ones that are in the ECMAScript standard? And this is also why I thought a chapter on that is necessary. There are so many programming styles and so many different variations of classes in both JavaScript and TypeScript that you really need to understand what is there, what are the implications of it, and which one should you ultimately use for the problem that you have? Or should you use one to begin with?
Yeah, I guess that's what the cookbook's for, right?
Yeah.
So the very last recipe in your entire cookbook is entitled Knowing When to Stop.
Yeah.
I think this is something that we can also apply to this discussion, but I have one final question. In my experience, every time I try to explain anything to anyone, I always learn something that I didn't know before.
Yeah.
Is there anything in TypeScript that you learned that you didn't know when you wrote this first proposal back in the day?
There is something, it's not what I would have expected. It's actually the features of the TypeScript playground. They are phenomenal. You can have entire projects, you can have entire courses within the TypeScript playground. You can load dependencies from NPM. You can define external types with it. There's a huge development environment hidden in what's basically a simple type checker. And I have an entire entry on that because it's amazing. So this was my biggest surprise.
Okay, great. Then I think we should close out with, knowing when to stop. I think we've given a great overview on your book. And I look forward to your third TypeScript book.
Oh boy.
Which is certainly coming, right?
I don't want to spoil anything, but yeah.
Okay, well, then let's stay tuned for this.
Yeah.
Thank you.
Thank you, Peter. As always, it was very fun talking to you.
Thanks for listening to this episode of the GOTO podcast. Head over to gotopia.tech to discover lots more content from the brightest minds in software development.